Let's have a circuit in with 2 bulbs, all right? You may know that in electricity there are 2 ways of connecting things up. This is the first one, which is series. Okay? These 2 bulbs are connected in series. They're in a chain, all right? Like a link in a chain, one after the other. This is a series circuit. These 2 light bulbs have been connected in series. Okay? Now let's see what happens in terms of voltage and current. Let's do the easy one first. Let's pop the ammeters in. Let's suppose the current here was 2 amps. I'm going to stop drawing the trucks now. But if you want to draw them on your circuit, then you would have, say, 2 trucks per second whizzing past. So this ammeter is counting 2 trucks every second. What's this ammeter going to read? This ammeter is going to read 2. The difference would be the trucks coming down here have got lots of energy in them. The trucks going back there are empty. But remember, ammeters don't care. Ammeters and voltmeters do different things, and they ignore each other. What the voltmeter looks at, the energy, ammeters take no notice of, and vice versa. Okay? Where in the circuit could I put an ammeter that wouldn't read 2? Exactly. Anywhere in the circuit, the ammeter would have to read 2. If 2 trucks per second leave the battery, there's nowhere else to go. They've all got to go all the way around. Okay? So let's make up some rules as we go along, because they're very simple. What's the rule for current in a series circuit? And you could have 25 Christmas tree lights. You could have 25 bulbs in series. But if this ammeter reads 2 amps, so must that one, because it's counting how many trucks per second. Trucks don't get used up. Here's a really simple rule then. In a series circuit, and by series circuit I mean any series circuit, if you're doing A-level physics and you get a circuit where there's a couple of things in series, this will still work. Any series circuit that you ever come across, the current will be the same everywhere. Because if it's a series circuit, it's just a loop, and there's nowhere for the trucks to go. Yes, they come loaded with energy, they give some energy out here, some energy out there and go back, but that's nothing to do with current. Okay? So current in a series circuit couldn't be easier. If they say the current here is 2 amps, it'll be 2 amps everywhere in the circuit, it has to be. Let's see if we can puzzle out what's going on with voltage, which once again is a bit more tricky. Okay? Let's again go for a 12-volt battery. I'll remind you, let's draw a couple of trucks. Trucks coming out have 12, trucks coming back have 0. Okay? Now, some people think that the first bulb, whatever that means, gets all the energy. Some people think it's shared equally. Some think this gets more than that gets nearly all of it, that gets nothing. Okay? And as you look at it, it's not always obvious. Here you are, think of Thomas the Tank Engine again. You set off in Thomas with is it the troublesome trucks, isn't it? The troublesome trucks behind you, load up with energy, you go jogging along here quite happy, get to the first bulb. Now, in the previous circuit, what did you do at the bulb? You just gave it all your energy, because it was the only thing in the circuit. But now there are 2 things, but we haven't got there yet. And it's because I've slightly misled you. I keep drawing electricity like a little train sort of setting off on a journey, but actually remember the little trucks are just groups of electrons. Where actually are the electrons? The electrons are all around the wire all the time. Okay? A better way to think about it, and I can't draw this very well, is if you imagine 3 people, someone with legs, and can you imagine between them a metal ring? I keep drawing it like it's a sort of a train setting off an adventure. I'm sort of suggesting that these bits of wire haven't got any trucks in them. It's because I'm lazy, I can't be bothered to draw trucks all the way round, but I should do. Really, if you want to, you go home, get a piece of railway track or something, get some little trucks. Technically what you should do is put trucks all the way around the circuit so the track is completely covered, like a train so long that it joins up with itself. A better way to think about it is like a metal ring. Imagine we have like a big metal hula hoop. So I grab hold of one bit, and if you can imagine there are 2 people here, they're blindfold, and they're holding the ring as well. So there's the 3 of us here, I'm holding the ring, they're holding it as well, but they're blindfold, they can't see what I'm doing. I'm the battery, they're the bulbs, and what I'm going to do is I'm going to start moving the ring. I'm going to move the ring round, because I'm going to start this current going. Which of the 2 people will feel the movement first? As I start to move the ring, which of my two people here is going to feel the movement first? Yeah. What if I did it really quickly? Doesn't work like that, does it? So you've got to imagine there's a constant ring of electrons. There's like a ring of electrons all the way around. If we're thinking of things to think about, the truck picture's pretty good, but because I can't be bothered to draw trucks all the way round, you need to think of it like a metal ring. In simple terms, the battery knows about the whole circuit immediately. The instant you turn it on, the battery knows about the whole circuit. Because imagine you are the battery, you're turned on, right, first truck, 12 lumps of energy, out you go. At the same time, what's the battery doing? It's taking the last empty truck in. So the battery, think of the metal ring idea, the battery knows about the whole circuit. Although I draw trains sort of setting off from this side and having a journey round, the battery is connected to the whole thing straight away. These two bulbs are the same, so actually, the only logical thing to do, if you come around here with 12, would be to give 6 joules of energy to that one and 6 joules of energy to that one. Okay? This truck in the middle is therefore going to have, how much energy will there be in this one? 6, isn't it? This will have 6 joules, this one will have 0. Remember the rule is you have to go back empty. Now, here's the important thing. Listen carefully. What will this voltmeter read and why? I don't want the answer so much, I want the sum. What sum is this voltmeter doing? It's getting the answer 6, but what sum is it doing to get the answer 6?
12 minus 6.
This one here is doing 12 minus 6. Trucks coming in have got 12. Trucks coming out have got 6. And the difference is 6. A voltmeter here, this might seem nitpicky, but it's important to get this right. Voltmeter here, surprise, surprise, that's going to read 6 as well. What sum is this one doing? This voltmeter is doing 6 as they come in, 0 as they go out, 6 minus 0, 6. Okay? What's the rule for voltage in series? The rule is shared. The good news about the whole of current electricity, you can do it in 4 words. What does current do in series? It's the same everywhere. What does voltage do in series? Get shared out. And if we could do parallel in the next 10 minutes, you can do any circuit. Because any circuit, no matter how complicated, is a mixture of series and parallel. Okay? Just before we push on, let's try this one. Let's imagine I connected my battery to this. You can draw this if you want to, you don't have to. Let's imagine I connected my 12-volt battery to this circuit. Here, you've got 2 different bulbs. This one is twice as good at taking energy as that one. Say that again. This one is twice as good at taking energy out of trucks as this one is. Okay? Still 12 volts, so you've still got trucks coming from the battery with 12, and they're still going back to the battery with 0. Would anyone like to suggest what the voltmeter might read if we put it across those 2? Still got up to 12. Remember, it's energy. Remember, you can't destroy energy or create energy. So if the battery gives out 12, it gives out 6 and 6 and comes back. You can't have 12 giving out 6 and 7. If I said this bulb's getting 7 volts, that can't be true. You only put 12 in. If you take 6 out, you can't then take 7 out. So it's kind of just conservation of energy, which you know well. Bearing that in mind, what's going to happen with this circuit down here? Any ideas? This one, the trucks come in with 12, 4 would be taken out, leaving it here with 8. And then 8 would be taken out and back it would go. This one is twice as good. Think of it like a pie eating contest. 2 people at a pie eating contest, there's 12 pies. And every pie you eat, your neighbour eats 2. So you eat 1, he eats 2. You eat 2, he eats another 2. What's going to happen when the pies run out? 4 and 8. Okay. Is everybody happy with that one? Fits our rule, doesn't it? Usually they're equally shared. Don't have to be. If the things aren't the same, they won't share equally. Okay. If we can do parallel circuits, then we have the whole of electricity done, and we can muck around and watch videos and eat sweets for the rest of the time. Okay. Sorry, I didn't. Oh, that's recorded, isn't it? Right, is everybody happy with what's on the board? The key thing It's these two. Are you clear in your mind? Current is the same in a series circuit. You could have 17 things, 3 penguins, a dustbin, a television, 3 small children and an eel. If you put them in series and 5 amps flows in, 5 amps flows out because it's number of trucks per second. Voltage gets shared out because it's energy. If you put 12 in, you can take it out as 6 and 6 if they're the same, or if you put 12 in, you can take it out as 4 and 8, any such combination. Okay? Right, let's see if we can. You'll need to redraw this on a different page perhaps. Let me see if we can now do it with parallel. If we can do that, we can do anything. Okay? Let's have a go at doing a parallel circuit. Okay? Thank you for your patience. Now, let's draw ourselves a parallel circuit. Let's stick with the 12-volt battery. Draw it quite big because we're going to be adding trucks and things in a minute, so it's a little too small. Those 2 bulbs, gentlemen, are connected in parallel. They're not connected in a long daisy chain. They're connected side by side with each other, like we did the voltmeter in the other circuit. Okay? 12-volt battery. All right? And we need to work out what the rules are for current and voltage. Okay? Let's draw some pictures in. There's a truck with 12 in. There's a truck with 0 in. You could do worse whenever you answer a question on this in the exam. Don't look at it and think, oh, nasty circuit, so I can't do these. Start drawing the trucks. 12-volt battery means the trucks leaving have 12 and the ones coming in have 0. In any circuit you ever see. If it's a 6-volt battery, it's obviously 6 and 0, and on you go. All right? Now, here come the trucks. They go belting down here, and they get to this point here. Now, this is where, again, the truck picture is really good, because what is this, if you've ever been on a railway, this is where you get to the points where the trucks spread out. Okay? What do they call them in America? Is it switches? Just thinking if this goes viral and people in America watch it. Yeah? They don't call them points in America, do they? Okay, type in the box below if you know the answer. No, I think in America they call them switches, don't they? But anyway. The trucks get to here, we'll edit all that out. The trucks get to here and the tracks divide. It's like points, it's like 2 tracks joining. So, some of the trucks will go that way, and some of the trucks will go that way. All right? What you could do, a really good way of understanding this, is like this. Okay? Can you imagine, as the trucks come out the battery, the trucks are painted. The first one is red, the second one is blue, the third one is red, the fourth one is blue. Can you imagine the train basically getting painted alternate colours? Red, blue, all the way along. Okay? When it gets down to here, again, I've only drawn a couple of trucks, but if you can imagine a whole train of them, as they get to here, there's a red truck, followed by a blue truck, followed by a red truck, followed by a blue truck. And then what happens is basically all the red trucks go that way, and then the blue trucks, every other one, goes that way. So this is what's happening here. It's like a set of points. So can you imagine the train basically like unzipping? Red truck goes that way, blue truck goes that way, red one that way, and so on. Okay? Very importantly though, let's put the energy in. Think what's happened to the trucks. They've kind of unzipped. Okay? They came along here with 12 joules of energy. Remember, it's a 12-volt battery, so the trucks were loaded up with 12 lumps of energy. They get to here, they've still got 12 lumps of energy because they've only gone across track. And this place where the train splits up, that's just track as well. So this truck here is going to have 12 lumps of energy. Yes, it's uncoupled from its neighbours, but that's got nothing to do with the energy inside. So this truck here, although it's the first one and the second truck's going to go that way, it's still got 12 lumps of energy. And so is this one. Let's follow the journey of this truck. It goes along to this bulb, and then it's going to come out of that bulb. Very, very importantly, watch what happens now. It comes through this bulb, it comes out of here, and look where it's going now. It's going back to the battery. Okay? How much of the 12 joules of energy must it give this bulb? Because it's going back to the battery after that, and the rule is when you go back to the battery, you must be empty. So this one must be given 12 joules of energy. This truck must give all its energy to this bulb and then go back. What about this one that went down here? That's got 12 lumps of energy in. But look again, even though the wire looks longer, watch, as it comes out of this bulb, it goes back to the battery. Okay? It goes back to the battery, and therefore it has to give out the full 12, because it's got to come out with 0. I can remember when I was at school in Year 9 looking at this and thinking, but surely it's going to share out the voltage somehow. Surely it's going to share out the voltage somehow. And a very good note for your margin is the reason why. I remember the phrase my physics teacher said to me. It can't share out the energy because no truck goes through both bulbs. If you were thinking, I've got 12 lumps of energy, I'm going to give 6 to that one and 6 to that one, you can't. Because if you go through the top bulb, that's your journey. If you go through the bottom bulb, that's your journey. No truck goes through both bulbs. And that's why you can't share out the voltage. You have to give the same voltage to each bulb. And in fact, I can remember at school actually trying to set this up. You could put 50 bulbs in parallel. Here's truck number 43. It goes all the way down to bulb number 43, goes through bulb number 43, and then comes back to the battery. How many bulbs has it been through? 1. And bulb number 43 gets the full 12 volts. Okay? So the good news is many people think parallel circuits are difficult. They're even easier. Because voltage in parallel is the same. If you put things in parallel, they all get the same voltage. Because they're in parallel, each truck can only go through one of them. It can't share out the voltage like it does in series. Okay? I can remember when I was at school trying to put like 15 in parallel to see if it was true. And I got to about 10 and my physics teacher stopped me, and you can see why. Because if you put 15 on a poor little battery, it's providing 12 volts to every single one of the 15. Can you imagine the energy level of the battery is just going down really quickly? You will just flatten the battery really fast. Okay? But the voltage in parallel is the same, and many people find this rather confusing, but again, the truck picture shows you why. Okay? Now, the good news is there's an even better way. It's hard to imagine, the truck picture is pretty fab. There is an even better way of understanding parallel circuits. Okay? I must admit, I've drawn a parallel circuit like this. Why have I drawn my parallel circuit like this? Any textbook in the room, the parallel circuits are drawn like that. I draw them like that because my physics teacher drew them like that when he was at school. He was teaching me. And I'm sure when he was at school, they were drawn like that. And pretty much every English-speaking book of physics I can find, that's how you draw parallel circuits. And a few years ago, I managed to talk to a physics teacher from Japan. And we got to, fortunately, he spoke very good English. And I was talking about the teaching of electricity, as you do. And I said to him, well, series is all right. People get their heads around series circuits, but parallel circuits are the one that really bothers people. He said, well, that's really interesting, because in Japan, that's not true. People have no problem understanding parallel circuits. There's no real difference in tests. People do just as well on series or parallel, whereas all the people I've ever taught physics to do better with series than with parallel. They find the parallel very difficult to understand, and particularly this really weird thing with voltage. The voltage, I mean, it looks like you've got 24 volts. If you've got 50 bulbs, it looks like you've got millions of volts that you didn't have to start with. It looks really odd, what we call counterintuitive. Common sense kind of says it shouldn't be like that, okay? It's my fault. It's because of the way I've drawn this circuit, all right? This is a mad way of drawing a parallel circuit. If you wanted to misunderstand something and confuse people, that's the way you draw it. But I promise you, you can open any textbook written ever, and this is the way they draw them. And after a bit of scribbled conversation on the back of beer mats, he showed me how they draw parallel circuits in Japan, and this is it. Why do both the bulbs get 12 volts? Well, duh. It's because they're both connected to a 12-volt battery. Why doesn't the first one get more volts? Well, there isn't the first one. They're both connected to the same battery. What would happen if you put 50 on? How do they all get 12 volts? Isn't that like 600 volts from nowhere? No, they're connected to a 12-volt battery, but they will flatten it very quickly. Do you see? Why is voltage the same in parallel? Many people find it confusing. I'm not surprised. Why would you have the two bulbs shared? Can you see these wires are shared? These wires are shared for some reason. Why would you draw it like that? This is a mad way of drawing parallel. Could I recommend everybody in their margin draw that? If you find parallel circuits difficult, you're not alone. Draw that. It's really obvious that voltage is the same everywhere. Parallel is a way of lots of things all being connected to the same battery. And therefore, get it? They all get the same volt. They must do. How can they get 6 and 6? It's ridiculous. Okay, so hopefully, parallel's the one to crack. All right, the nation's youth, of which you're part, generally does very badly on parallel circuits, even at A-level. You can picture what's happening. Okay? Now, final bit. Thank you for your patience. Let's see if we can do current. We can do the whole of electricity in 4 words. In series, current's the same, voltage is shared. In parallel, very surprisingly for people in the English-speaking world, anyway, voltage is the same. But if you draw the circuit properly, you can see it's kind of obvious. Okay? If you think the whole of the English-speaking physics teaching world is mad, why do they keep drawing parallel circuits like this? I think it's because this is a wiring diagram. If you want to teach people about parallel circuits, this is the way to draw it so they understand. But actually, have a look at this. In this room, we've got 1, 2, 3, 4, 5, 6, we've got about 12 strip lights. Each of these has each of these has a voltage of 240. If I wired up the room like this, so the wires come in from the mains over there, I take 2 wires from the mains, and I run up to that first light socket, 2 other wires to that one, 2 other wires to that one, 2 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 wires to that one. Would it work? Yes. Think, we'd have to bury it all in the wall. Think how much wire there'd be in the wall. It's just ridiculous. This is much better. This is a wiring diagram. I don't know why it's got into physics teaching, but this is a wiring diagram. If you want to wire up this room, here's a bank of 6 strip lights. What do? From the mains, you take a live and neutral, you take 2 wires, you bring them up to here, and then you go to that one, to that one, to that one, to that one. If we dug in the wall and said, how many wires run from the mains to here, it'll be 2. There'll be a pair of wires that just come over to this light fitting, and then you have a set going to each socket. Okay? This, gentlemen, is a wiring. If you become an electrician and you want to wire up the light fittings in a house or something, that's how you do it, because it saves wire. Instead of having, 24 sets of wire, you only actually have 2. You have 1 pair of wires to that one, 1 pair of wires to that one, and on you go. Okay? But why this is always in physics books, I do not know, because this is the way to understand parallel circuits. Okay? Right, current's quite easy now. Let's suppose we had put our ammeter there, ammeter there. Let's put an ammeter here. Sorry, it's getting a bit scribbly. Hold on to it. Put your ammeters in. Let's see if we can work out what's happening. Let's not draw in red. Try and use a different colour. Let's suppose the ammeter there reads 6. That means 6 trucks per second are coming past this point. The ammeter here is going to have to read 6 amps. Now, again, go back to railway mode. Think about the split in the track where the points or the switches are. 6 trucks per second come along here. The train unzips. The first truck goes that way, the second one goes that way, the third one goes that way, the fourth one goes that way, the 5th one goes that way, the 6th one goes that way. How many trucks per second will be going along here? 3. How many trucks per second along here? 3 again, isn't it? All right. What's the word for current then? Shared out. hopefully now you can see the pattern. This little diagram here, which is the final thing, pretty much. Let's think about current and voltage, all right? Let's think about series circuits and parallel. Current in series is the same everywhere, and current in parallel gets shared out. Voltage in series gets shared out, but voltage in parallel, rather spookily, is the same. Now, good news. The only things you need to understand electricity are current and voltage. There's other mad made-up things like resistance, we'll come to another time, but current and voltage are the key things. Because electricity is about, remember right back at the beginning, electricity is about electrons circulating so as to deliver energy. If you understand current and voltage, then you'll understand what's going on. Okay? Series and parallel, there's no other way of connecting things. So your exam paper, which you open on the day of your exam, it'll have different circuits in. They'll be different to the ones I've drawn here, but they will contain series and or parallel. And so if you know these 4 words, you can do the whole of electricity. Current in series is the same. Current in parallel is shared out. Voltage in series is shared out, and voltage in parallel stays the same. Okay? Why that's true, many people learn that without really understanding it, and then they go and want to put 6 and 6. All right? If you ever get confused as to why, you can use the little truck carrying energy way of thinking, and you can always work out what's going on.